So as I mentioned before, we will be facing a situation regarding the motion blur of the tire. I'm going to make sure we're only going to be testing the tire for now. So let's just select the tire and let's go with half resolution for our renders. I'm also going to be disabling the global illumination. That's not really relevant at the moment. And I'm also disable here. Don't really need to see the lights on the viewport or the camera. And the next thing I want to do is on the camera, make sure you turn on your motion blur. Make sure you're not on frame 1. You need to be on a frame where it's spinning really fast. And let's see what this gives us. Okay, so this was what I really wanted you to see. You should notice that there's an issue with the motion blur. Even though we already increased the subdivisions or the subsampling here, the number of sample for the tire is at 4. We do have this issue. We should never have any transparency here because the tire is always, it's just rotating. But that's also the issue. Since we have really fast rotations, the way the motion of the tire is being interpolated is actually incorrect. And there really isn't a good or a simple fix for this. I'm just gonna show you what's wrong, what's being considered as the motion of the tire to give us this result. And then as a solution for this, I'm actually gonna import the animated geometry that I had on my previous file. So let's have a look at what's actually happening. I'm going to go here to our burnout sim where we already did some testing on this. Let's go here. We had our read time. Let me actually just put a blast here and let's say we just blast. Let's grab 3 points. So I'm getting 3 points. And we do a trail of this. And at this time, as you can see, this is the motion that we're going to be getting from those 3 points. And it's not circular at all. This is also at the origin of that pattern that we get when we have a look at the points that we cache and we look at the temperature. At top speeds, we get these 3 points or these 3 areas that are very hot, and that has to do with the same issue actually. So if we look at those points and if we move this out, everything seems okay, right? But what's actually happening is whenever we tell Houdini or V-Ray to interpolate or to analyze in between frames what's happening, and we can check that out as well. Here, if you go to your time settings, if you turn off the option for integer frame values, you'll actually get float frame values, and you can check in between frames. So as you can see right now, if we look at the cache, we don't see anything special happening because the file cache only has frame and frame. But if we look at this read time, you already see that there's something weird going on. So this is the type of motion that's actually being considered when you tell V-Ray to sample in between frames to do 4 samples in between frames. It's going to detect that in between frames, this is rotating so fast that the interpolation that it's doing is actually very incorrect. And the reason for that is because if we look at a few points, let me just actually have one. If we look at the position of 1 point at frame, let's go back to integer frames. At frame 48, we have this point here, and at frame 49, that point is there. If you look at the trail that this does, this is the trajectory that's being considered. Let's actually go to a side view. This is the trajectory that's being considered from frame 48 to frame 49. This is the trajectory that's being considered. So it's just spinning so fast that when it tries to interpolate, even based on the velocities that we've set, and if we look at the velocities, we do know that the velocity of this point actually makes sense. Okay, it is facing a tangent to the circular motion, but it's still not allowing us to get a proper result on the trajectory of the point. Even if we lower this to 0.1, which is going to give us just the position interpolated between one frame, between two frames, it doesn't give us nothing like a circle. When we're slower, when it's going slower, then in the beginning it works kind of okay. We get that arch, but it's still working incorrectly. One way of fixing this, or one of the elements that's actually contributing to this, is the fact that we are clamping the velocity. So if we go here to the speed, and if we do not clamp the speed, now we set the maximum speed to 8, but if we do like 99, the trajectory should be a bit better when we're at higher speeds. Okay, so it isn't as bad as if it was as before at 8. So there is a correction. But it's still not going to be able to do a perfect circle. Okay. Now, there isn't really a way of solving this, and let's just make sure that you see the circle. So we're still far away from the reference circle. This is the trajectory that we should see as a trail for every point, but we can't really get there. It's just rotating too fast, and the deformation doesn't allow us to get very precise motion in these cases. If it was just being translated to really fast, then that would be different. But something that's just spinning around itself, the points move in between frames. They move into positions that gets really hard for us to be able to interpolate properly the trajectory in between frames. So this was just to show you what's actually happening in between frames and what's causing that weird motion blur that we're getting. So the solution for this, we could try and fix this. It would be a bit complicated, and I don't want to spend too much time on this. It goes beyond the scope of the workshop at this time. So what I'm going to do is I'm actually just going to go up, and instead of us rendering the deformed tire that we're using as the Alembic, we're going to use, for rendering at least, we're going to use the setup that I had where I'm on my other file, my original file, where I actually animated the rotation of the tire. And in that case, since we have the rotation of the tire, it's going to be properly blurred with when we render with motion blur. So instead of render tire like this, I'm going to go to the other file and bring in the setup that I had. So this was the setup that I was getting. This point was actually referencing the object tire geometry prep out center point, and that center point is coming from, is actually coming from here. So here I'm just doing the same thing. In my case, I had the full car. I was blasting everything except the tire, adjusting scale, position, applying the materials and all that stuff. And then I aligned the tire because it wasn't really properly aligned. And after that, I would get the center point. And this is the center point that's being referenced by that null here. This null is at center point. And then I am parenting another null that's going to be used for animating the rotation on the x-axis. And that's going to make the tire rotate. So here on the tire rotating, this is looking for something that's coming in up out of that geometry prep as well. Okay, so now you have the whole setup, out rotating, out static, and yeah. So now if you have a look at the part of the, I'm gonna actually turn this one off by adding here a knot. So this is not going to be renderable. I'm gonna kind of gray it out. And if we now have a look at, even through the camera, I don't really need to see this, but the tire rotating, if we go here to the time settings and turn off the integer frames, and we have a look at the float frames, the space in between frames, you'll notice that the rotation is always going to be correct. Okay, and this makes all the difference for us to get the proper motion blur. The speed is exactly the same, the speed variation, everything is exactly the same. I just baked this out into an Alembic so that it would be easier to share with you, but because it is something very common as a pipeline workflow to work with Alembics coming from other 3D applications. But in this case, you really needed to have the proper rotation and in between frames. So let's go back to integer frames, and let's go to frame 48, and you'll notice a huge difference. So here on the renderer, I'm actually going to include the ground and the render tire rotating and the render tire static, accept pattern, and it's going to be pretty obvious, the difference. Let's just save this one, and that way we can properly compare. Okay, and this is the correct motion blur we should be getting. If you render this with the smoke, we do get a really nice sense of motion. Even if you just render a still image, you're really going to get a nice sense of motion and speed going on, and it's going to give you a pretty cool result. So this was just mainly to address that issue with the motion blur. You can also, of course, try and resimulate if you want based with this on this motion instead of based on the deforming mesh. It's not going to make that much of a difference in terms of the result that you're going to get for your simulation and the way the temperature evolves throughout through time. But it is an option for you to consider as well. So the motion blur is fixed, and next we're going to set up our have a look at our render settings for the final render.